Hello college algebra student, this video is for chapter 3.7, inverse functions, second part, about restrict domain and also how to graph an inverse function. So why do we need to restrict domain? Because some function is not one-to-one. And if it's not one-to-one, that means if you do an inverse, you can have same x that go to 2y. So what we can do is we can restrict the domain by choosing an interval of f of x as non-decreasing. So it's like always increasing that part. Then find the inverse in the restricted domain. So a very good example would be like this one, x squared plus 1. Okay. So we know how to graph x squared is the parabola with the point at 0, 0 plus 1 means it's a vertical stretch. No, not vertical translation or shift 1, right? And so if you do a horizontal line test, you would have 2 points here. So how do I restrict the domain? That means don't use those x value that will cause me to have 2 points when I do the horizontal line test. So what we can do is we'll restrict only this part as my f of x. The whole thing is f of x, but I'm just restricting it so that this is non-decreasing. It is an increasing function. Right? From x equal to 0 to x into infinity. So I would say because usually if you graph it, then you can see which part would work. Oh, plus 1, right? And we'll just restrict this part. Part of it is, well, why don't you restrict this? If you restrict this, it's like a decreasing function. We like increasing function more. Okay, it's easier to work with the increasing function. It is non-decreasing. So what is the domain? The domain is from 0 to infinity. So the restricted domain would be, that means your formula is still y equal to x squared plus 1, but you would use from 0 to infinity. So when you do the horizontal line test, it's just 1 point, right? So it is a one-to-one function. What is the inverse then? The inverse would be, you do the same thing as before, x squared plus 1, solve for x, y minus 1 equal to x squared. How do you solve for x? You do square root of y minus 1, just the positive one. Because we have restricted here, y is always positive, so that means we want x to be all positive, or actually x is positive. So the inverse function will be x minus 1. So that is the inverse. F inverse of x is equal to the square root of x minus 1, where x is greater than or equal to 0, or from 0 to infinity. So that is the restricted domain. Do another example. Do another example. Find the restricted domain of x minus 3 squared. So do you still remember how to graph this? This can be graphed by shifting to the right by 3. So 1, 2, 3. Still a parabola like that, right? And I want to restrict it from this side, right? So what is the domain? The domain would be like that. Start from here. So be 3, comma, infinity. So that's a restricted domain. The inverse would be y equal to x minus 3 squared. I want to get rid of the square first, so I square root y only, and then x minus 3. And then I do plus 3 plus 3. So square root of y plus 3 is equal to x. I solve x. Now I switch x and y. So x plus 3 is equal to y, and this is the inverse function. Square root of x plus 3. But I would want to restrict my domain to the domain is 3 to infinity, and then the range, you can see that the range is from 0 to infinity. So the domain for this would be from 0 to infinity. So you can see that you can only do from 0 to infinity. The last part is graphing inverse function. If sometimes your function doesn't have a formula, and I want to sketch a graph of the inverse function. So you give a graph, this is f of x, and I want to sketch f of inverse. So how do I do it? The idea is, if there is some point xy is on f of x, yx will be on the inverse. So I just want to get some point. This point is good. This is on the grid, right? This is on the grid 0, 0. So I would say F. I have X, Y, 0, 0. This is 4, 2. F inverse, I will have the same 0, 0. Switch is the same, but 2, 4. So I'll graph this point and then 2, 4. And it should be like that, right? So that is the inverse. You can graph it. If you want to, you can do more points. I'll graph the same inverse. So I have a lot of points. So this is a line. So it's easiest is to graph those on the grid. So it is easy. So the function itself, x is 0, 3 is the y-intercept. It would be nice if I have x-intercept, but I don't. So this is 2, 2. So on F inverse, it would be xy again, but I switched the order. 3, 0 and 2, 2. So 2, 2 is the same, but it's 3, 0. This line. And you can see that this is symmetrical on x equal to y. The other one is also symmetrical on x equal to y. This is kind of like the mirror that reflects them. So that's how you do a graphing of inverse.